Hi, so today we're going to talk about chemical reactions and enzymes. So a chemical reaction is a process that changes one set of chemicals into another set of chemicals. Some chemical reactions occur very slowly, such as the combination of iron and oxygen to form iron oxide, also known as rust, and other reactions occur quickly. For example, when hydrogen gas is ignited in the presence of oxygen, the reaction is rapid and explosive. So the elements or compounds that enter into a chemical reaction are known as the reactants. So in this example, CH4 and oxygen, O2 gas, react to form the products, which are the elements or compounds produced by the chemical reaction. So the reactants are what we start with. After the reaction occurs, we end with the products. Chemical reactions always involve changes in the chemical bonds that join atoms and compounds. So basically, atoms get rearranged. Some bonds break and others form to give you completely different compounds as the products than what you started with. So there's always energy involved in chemical reactions. It's either released or absorbed. And this happens every time chemical bonds form or are broken. So because chemical reactions involve breaking and forming bonds, they involve changes in energy. So chemical reactions that release energy often occur spontaneously. Chemical reactions that absorb energy will not occur without an original source of energy to get them started. So an example of that is when hydrogen gas reacts with oxygen to produce water vapor, it is an energy-releasing reaction in which energy is given off as heat. But reversing this reaction would require the addition of large amounts of energy. So this is spontaneous, and it releases heat. But if we take water and we want to turn it into hydrogen gas and oxygen, it requires an input of energy. So in order to stay alive, organisms need to carry out reactions that require energy. We need to get the energy from the food that we eat, okay? So first of all, we have to get the energy to break down that food into compounds that we can use, and then we've got to use those compounds to actually release energy. So because matter and energy are conserved in chemical reactions, every organism must have a source of energy to carry out the chemical reactions. Plants get their energy from the sun, and animals get their energy from eating plants or other animals. So we get our energy from the food that we eat. Chemical reactions that release energy do not always occur spontaneously. Chemists call the energy that is needed to get a reaction started the activation energy. It's the energy needed to activate the reaction. Okay, so it won't just happen on its own, or it'll take so long for it to spontaneously happen that it's not worth it. So activation energy is a factor in whether the overall chemical reaction releases energy or absorbs energy. So here's an energy absorbing reaction. If we look at this graph, here's the course of the reaction. So we start here with the reactants and with the products. This is the amount of energy. So we start down here, and this is the amount of energy required to get the reaction to start. It's like pushing a ball up a hill. It's the amount of energy you have to add to it to get that ball over the hill. Once you get it over the hill, it spontaneously goes down the other side. It doesn't need any more input of energy. So here's the reactants, and here's the products. The reactants have way less energy than the products do. That means the products absorbed that energy. In an energy-releasing reaction, it's the opposite. The reactants start here. Here's the activation energy needed to get it started. Once the reaction goes, the products have less energy than the reactants, therefore that energy was released. So enzymes. Some chemical reactions that make life possible are too slow or have activation energies that are too high to make them practical for living tissues. So these chemical reactions are made possible by what we call catalysts. A catalyst is a substance that speeds up the rate of a chemical reaction. So a lot of the reactions in our body occur too slowly, so we need something to speed them up. Otherwise, we wouldn't survive. What catalysts do is they work by lowering a reaction's activation energy. So lowering the amount of energy needed to get that reaction started. Enzymes are proteins that act as biological catalysts. So enzymes are what's going to lower the activation energy in biological reactions. So enzymes speed up chemical reactions that take place in cells. They act by lowering the activation energy, and enzymes are very specific, generally catalyzing only one chemical reaction. So if we look here, here's the enzyme, okay? It has what we call an active site. This is where the substrate, and we'll learn this in a minute, but a substrate is the reactant in the chemical reaction. This is where the substrate binds to the enzyme. So enzymes are very specific. Like lactase only reacts with lactose sugar. It can only break down lactose sugar. It can't break down glucose, can't break down any other sugar. So it's very specific because it's got a specific shape. So lowering the activation energy has a dramatic effect on how quickly the reaction is completed. So here's a reaction without an enzyme. It requires much more activation energy to get it started. But with the enzyme, it requires less energy, so therefore the reaction occurs faster. So for a chemical reaction to take place, the reactants must collide with enough energy so that existing bonds will be broken and new bonds will be formed. If the reactants do not have enough energy, no reaction will take place. So it's like you saw in the video. Closely packed together, those atoms can react very quickly. But if they're far apart, they're most likely not going to react until they come into contact with each other. So what enzymes do is enzymes going to help bring those reactants together so that it happens quickly. So this is called the enzyme-substrate complex. Enzymes provide a site where reactants can be brought together to react, reducing the energy needed for the reaction. The reactants of enzyme-catalyzed reactions are known as substrates. So reactants are the same thing as substrates. Okay, when you hear substrates, it's just a reactant. So here is the enzyme. Here are the reactants, or the substrates. They are brought together by the enzyme so that the reaction can occur. So those won't spontaneously react with each other, but when you have the enzyme come in, it can help the reactants react with each other. So the substrates glucose and ATP bind to the active site on the enzyme hexokinase, forming an enzyme-substrate complex. I'll show you guys a picture of this in just a minute. The fit is so precise that the active site and substrates are often compared to a lock and key. The enzyme and substrates remain bound together until the reaction is done and the substrates are converted to products. The products of the reaction are released and the enzyme is free to start the process again. So here's the reaction. Here's a hexokinase. Here's the active site where the substrates bind. Here are the substrates, glucose and ATP. They bind to the enzyme. They're converted to products, so their bonds are rearranged, just like in a regular chemical reaction, and the products are released. You get glucose 6-phosphate and ADP is the products of this reaction. So enzymes can be affected by any variable that influences a chemical reaction. Enzymes work best at certain pH values. Okay, so if the pH of your blood changes, it's around neutral. If it changes, your enzymes are not going to work as well, so chemical reactions aren't going to work as well, so your cells are going to start to die. Similarly, many enzymes are affected by changes in temperature. Okay, so if you change the temperature, say you get a really, really high fever, the reason why you feel sluggish is because the enzymes that create the energy for your body can't work as quickly in high temperatures. So you feel sluggish because you can't make energy for your body. So cells can regulate the activities of enzymes. Most cells contain proteins that help to turn key enzymes on and off at critical stages in the life of a cell. Enzymes play essential roles in regulating chemical pathways, making materials cells need, and releasing energy, and transferring information. And that is all for today. Thanks for watching.